All right. Guys, today the topic is very popular because this is the backbone of many of the concepts, specifically when we're talking about REST, HTTP protocol, which is called promises, right? We have Axios, we have Fetch. Whenever we are making an API call, these promises are going to play a very crucial role. We know we have many wrappers on the top of this promises, which is a JavaScript code concept, but still, I would like to emphasize more on this. Would with this session, my aim is to explain this JavaScript promises in a very simplistic way. Um, Try to correlate it with the real life analogy, and then we'll see some of the compiled JavaScript promises code walkthrough, so that you get to know the understanding of the polish promises in a better way. So promises. Java promises, they are used to handle asynchronous operations, right? I think this is the thing which everyone knows. Promise represents a value that may be available now or in a future or never. These are the three things which are always associated. Okay, it is a very common thing which you do in your real life when you have a promise with anyone. So you have your promise available now, or you can make a promise for a future, or it can never ever work. So promise in JavaScript, it is also an object that acts as a placeholder for the future results of an asynchronous task. Okay, promises have three states: pending, which is the initial state; fulfilled, operation completed successfully; and rejected, when the operation is failed. This is the very basic understanding of promise. Let me try to correlate promises with a real life analogy. All right. So, again, I'm trying to explain everything in JavaScript with real life analogy. I really want to correlate things. I mean, we are humans. We have created so many things, but to be honest, I always think whatever we discovered, whatever we have invented, somewhere at some point we have those pointers coming in right from the nature, right from the real life, right? So that's why I would like to again give a real life analogy for the promises. So let's say there is a scenario, you're ordering a pizza. So when you're ordering a pizza, what will happen? The very first state will be the promise creation. When you order a pizza, you get a receipt, which is a promise, is a promise that you will get your order. Then pending state. So the pizza is being prepared. This is the time when you say the promise is in pending state. Pizza arrives at your doorstep, which is a fulfilled state. Order gets cancelled due to unforeseen reason. It could be payment issues or some other issues. So this is called rejected state. So very simple real life analogy wherein you can explain promise creation, pending state, fulfilled state, and rejected state for your promises, and so called for your pizza. When you order is a pizza, you get a receipt which is a promise. So that is pretty much all when it comes to correlating with the real life analogy. We can correlate it with many other examples wherein we can have all these things possible, right? Creation, pending, fulfilled, and rejected. Okay, not wasting too much time, let me quickly go into the real time compiled questions which I have prepared for you guys, and we'll see how exactly these questions will play a very important role in the understanding of the promises. Over here, you see, we have a pizza order. All right, I created a pizza order, and we created an object called new promise. We have two things: resolve and reject. And then what we are doing, depending on is delivered depending on is delivered, it either resolves or reject. And then there is a method which is called then, which handles success, and catch, it handles failure. All right, so what will happen? So if you see this code, you will see that change to false if you want to test the rejection here. You want to see the error block, and change to true if you want to see the success behavior of the promise. So because the value of is delivered is true, meaning the promise is resolved successfully. All right, so it will print pizza delivered. So let me quickly run node promise q1.js, and pizza delivered is the right answer. All right, now if I make it false, you see pizza delivery failed because it goes into the reject state. All right, question number 2. Question number 2 is about very important concept when we are chaining promises. We talk about chaining promises. So we have make pizza and delivers pizza. These are two promises which we have. All right. So make pizza resolves after 2 seconds, and deliver pizza resolved after another 2 seconds. Now, chaining ensures each task completes in sequence, and this is the why we have chaining concept. So we all, if let's say we want to ensure that we want to complete each task in a sequence, we should use chaining here. All right, so let me quickly run this and show you the output of this. So it is very simple to understand. Pizza made after 200 millisecond, 2000 millisecond, which is 2 second. Pizza delivered. All right, so what is happening? So over here, make pizza and then dot, then the result of, so make pizza will be called. When this make pizza will be resolved, which is after 2002 seconds, then we print it make pizza, I mean the pizza made. And then we have deliver pizza over here, because this was the delivered pizza is pizza delivered. So after another 2000 millisecond, which is 2 second, we again resolve this deliver pizza with console.log result. So make pizza resolve here. All right, and then from here we are nesting or chaining the promises. So from inside this, once we resolved it, we want to chain it to pizza delivered. So we return delivered pizza, and this delivered pizza, because this is also a promise, we need to resolve outside of this function. So we do then resolve and console.log. So this is how question number 2 is explained. So question number 3 here. All right. So question number 3 is a very good when it comes to usage of if let's say if you want to resolve all promises, right? All promises. So if any of the promises reject, the entire chain fails. So over here, you have a chain of promises which you have inside. But promise.all, it can help you to wait for all promises to resolve. So unless these all promises are not resolved, let's say this is 1000, 2000, 3000 milliseconds. So after 1, 2, 3, which is like uh, all the sum of all those seconds, after that, this all will be printed. All right. So what will happen? So let me run this. So this will return an array of results, right? Array of results from every single promise that has been resolved. That is why we have results here, right? Not result, because you're passing a chain of, and this is a very good example when you want to execute, let's say, after all promises are resolved. But remember, promise.all, you have to always make sure that if any single promise fails here, let's say this task 2, if it fails because of some unforeseen reason, the entire chain will fail. All right. So let me quickly run this question number 3. Here we go. Task 1, task 2, task 3 completed. I think it's pretty easy to understand. Now, question number 4, which is promise.race. So we have task 1, we have task 2. So task 1 is a promise, okay, which is resolved after 1000, meaning 1 second, and the other one is after 500 milliseconds. So promise dot raise resolves or rejects based on the first promise to settle. All right. So again, promise.raise, what exactly it do? It resolves or rejects. It can do, it can either resolve or reject, but it will based on the first promise to settle. So whichever first promise it has to settle, it will be it will be resolving the. So here tasks to resolve faster than task 1. Why? Because task 2 is resolving after 500 milliseconds, and this is taking 1 second. All right. So promise.raise resolves, the whole promise.raise will resolve uh, based on the first promise to settle. So if I run this, question number 4, here we go. Task 2 is printed. Why? Because we say, hey, promise, you have to do a race. But when you say race, you can call it in the real life, right? The one who wins, who do it very fast, will be the winner. So we are racing task 1, task 2, all these promises. The one who is the fastest will be the winner in the result. So it will resolve or reject. It can be both situations, but it will work with tasks 2. So let me go and take question number 5. All right. So over here, we are kind of dealing with error handling in promises. So we have a fetch data. Now coming to the real, let's say we have a fetch data API, okay, some API call. Now what we are doing, we are creating a promise. We are returning a promise from here. Success is a false, so that we can simulate the error flow, the reject workflow. And now what will happen that once the promise over here we resolve, it will go to the error block console.log error, and then what will happen that finally will executes after then or catch regardless of the outcome. So this finally here, which is a very important thing to understand, will always be executed no matter what it is gone to then or catch. So over here it will go to catch definitely. So let me run this. Question number 5, you see error fetching details and operation finished. So this is sometimes important when you try and understand, try and have to take care of the error as well. You have to execute some of the notification email or things like that when you get the error. All right. Or let's say you want to do some cleanup operation, which is where we use finally. Question number 6. All right. So this is a real example. So fetch. I think everyone know this fetch. So it is used to work as a wrapper on the top of what we used to do in basic Ajax. If you have done with Ajax, so fetch will return a promise, and then we are resolving it here with then and then and then we are saying dot catch. So fetch returns a promise, then parses the JSON data, and then we have a catch which will be used to print the errors. So question number 6, here we go. So you see, this is the output. It will call this, resolve the promise, and it will print into the console log because this was JSON, so we have to pass this into JSON object, right? Question number 7. Uh, well, this is a very good example. We are talking about custom promises, all right? Uh, Custom promises timeout. So what is happening here? A custom timeout function returns a promise that resolves after a specific time. Okay, that is the thing which we have to understand. We we should always remember that if we have a custom timeout function, okay, let's say this is a timeout function, okay, and this is returning a promise that resolves a specific after a specific time. So let's say we pass here 2000 milliseconds. So this promise should be resolved after 2000 millisecond. All right. And then the message should be displayed. So let me run it quickly. Question number 7 over here, 2000 milliseconds. Here you go. Resolved after 2000 milliseconds. So this is way how you deal with custom promise timeouts. Um, and then, all right, question number 8. Question number 8 is very good topic because we we are here promised with multiple then calls. I think we have already seen this in fetch API, but yeah. So each then, whenever you have multiple then each then receives the previous value of the previous then. Okay, that you should always understand. So process order is the promise. When you resolve this, it will return you order process. So you have order process here. So will be printed, and then you have return pizza baked. So over here, return pizza bake will come, and then you have finally you are resolving step 3 at so step 3 will print this pizza delivered, and console.log will print whichever is coming in from the previous state. So if I run it, so you see order process first and then pizza baked. All right. Because order process will be printed here, pizza baked will be printed here, pizza delivered will be printed here. I hope this is pretty clear. Okay. So now we have next question, which is where we are trying to is open equal to false. We are trying to reject a promise. So rejecting a promise, as I said, is already clear. It will go to this reject, and then console.log. This catch will be executed. This is question number 9. And restaurant close is something which you will see as an output. Question number 10, async and await. We have a fetch user, let's say it's an API call, we're returning a promise. All right, so what we're doing, set timeout is a method, 2000 milliseconds. After that, it will resolve. There's an object ID1 named John Doe, and this is a main method. We have async here. We are calling fetch user, await. See, there are many concepts which are working behind the scene, right? We're using await here, which is an asynchronous part. So async await make promise based code looks synchronous. That's the only thing why we use async await. Await waits for execution until the promise is resolved. So until the promise is not resolved, it will wait. So it will wait for 2000 milliseconds. And once this object is retrieved, we have user here. User fetched will be printed, and then it will print the final logs, right? So push number 10, it's here. So you see it's taking 2000 milliseconds. This is where await is working, right? So you see user fetch is not printed unless this is not resolved. That's pretty much all from the promise, JavaScript promise side. I hope you like my videos. I hope you like my life analogy of correlating every concept in JavaScript. I hope you like the way I explain all these concepts in real time with the code walkthroughs. I see you in another video.